So this is going to explain a little bit more about dosage calculations and how it's actually applied for anyone who's still confused about actually how to do it. So imagine you're actually at the hospital and you get an emergency code. So you being the amazing nurse that you are, decide that you're going to grab everything out around you and run to go see what's going on. Unfortunately, like always, we never really get to do what we want to do. And once we get there, we realize that there's actually a physician in the room and he's going to tell us exactly what he wants done. And this is where they end up telling us that they want a medication and how they want it. This is the dosage required. Once you're given the dosage required, you actually get to do something, go over to your medical cabinet, pull out some medication, and it's then that you realize that it's in milligrams per milliliter. For a lot of people, this can throw them off because they're not sure how to get the equation down when it has a measurement of volume. So for this next part, I'm going to take you through how you actually go through and set up your equations and what it all means. Alright, so for everyone who's still confused on how the equation works, this is the step-by-step breakdown on where things come into place. This is going to be the same for any of the questions on the packet or anything you come into in actually working your clinicals. So when you go and actually see the physician and he says that he wants a medication, he's going to give you the amount. That, for our equation, is the dosage requested. He is requesting 500 milligrams. Okay? It doesn't really matter for our purposes what the medication is. It just matters the measurement. He wants 500 milligrams of the medication. So that's our dosage required. Once you go to the medication cabinet and you actually pull out the medication that he wants, you realize that it is the 500 milligrams, but it's in per milliliter. All it's saying is that for every milliliter that you draw up, there is 500 milligrams in it. This, the weight, the milligrams, is the dosage supplied. You are being supplied this medication. There's nothing else to use. This is the medication you have. This is what's being supplied to you. Anything that is in a volume measurement, fluid ounces, milliliters, cc's, that is all measurements of volume. And this is the volume. So for our equation, dosage requested over the dosage supplied times the volume. That's all it is, every time. So the doctor said he wanted 500 milligrams. And your medication, the dosage supplied, comes in 500 milligrams. And per means for every 1 milliliter. Since there's not a number before it, it's just assumed to be 1. So per is for every 1 milliliter. So your volume is 1. This is the volume. You're actually not dividing, I'm just labeling it. So this is volume. So all you do is divide your numerator into the denominator. That will give you a number. And then you take that number and you multiply it by the volume. And that is the dosage required divided by the dosage supplied times volume. Doesn't matter what numbers they give you, you're going to divide top into bottom and times by the volume. If this medication said 2 ml, then you would have 2 over here. So it'd be 500 divided by 500 times 2. If it was 3 ml, it'd be times 3. If the doctor said he wanted 1,000 milligrams, instead of the 500, you would still do the same thing. His order was for 1,000. So you divide that into what is supplied, the 500, times whatever the volume measurement is. So that'll give you the answers to 99% of the questions on this packet. If you do it another way and it works for you, that's great. But for me, it's a 3-step process and it always works, and it's really hard to get confused. Whenever you read the question, whatever the doctor is saying to give, that is the dosage requested. Whatever amount is on the bottle, that's the supplied. And then whatever the measurement is in volume, you just plug that number in, divide, and multiply. So I hope that helps you guys out. Okay, this video is going to go over the second packet she gave us. I know I told some people I was going to do all of them, but 90% of them are the same equation over and over again, so if you know how to do it one time, you can just repeat it and do the rest. I also included the problems that are a little bit different from the standard dosage required divided by dosage supplied times volume. So with number 1, the doctor requested 500 milligrams and it came in 400 milligrams, and that was per 1 milliliter, so it's 500 divided by 400 times 1, so 1.25, round up 1.3. Number 2, the dosage required was 110 micrograms. The dosage supplied was 0.5 milligrams per ml. So your first step is to convert the dosage required to the same unit as the dosage supplied. So I did 110 micrograms divided by 1,000 to convert the micrograms to milligrams. So we're still working with the dosage required. So step 2 is to set it up, the dr over ds times v. So our dosage required was 0.11. So you're just going to bring that over. And then you're going to just divide into the dosage that was supplied times the volume, and you have your answer again. Number 3, the dosage required was grain 1/200, and the dosage supplied was 0.4 milligrams. The first step is, because you're starting out with a fraction, you have to solve using a fraction. So step 2 would be to set it up 1/200, and this whole section is a grain still, is equal to, and we need to get it to milligrams because that's what our dosage supply is in. So we know 60 milligrams is equal to 1 grain. So we can cross multiply, and we get 1 over 200 is equal to 60 over 1 is equal to 60 over 200, and then you divide numerator into denominator, and you get 0.3 is your dosage required, and the dosage supplied is still 0.4. So then you put it into this equation over here, and it's 0.3 divided by 0.4 times the 1 milliliter is the volume, 0.75, round up to 0.8. Number 10 was straightforward, but just to put in another one, there was 10 milligrams was requested. Our bottle had 5 milligrams, so divide and multiply. 10 divided by 5, dosage required divided by the dosage supplied equals 2 times the volume is 2 milliliters. And with number 8, you had to find it in the label. Again, this is help thanks to Stephanie. It points out that you get 50 milligrams per 1 milliliter in the text, but the doctor is asking for 0.5 grams. So you need to convert the dosage required from grams to what you have on hand, which is the milligrams. So to convert it, it's 50 milligrams. That's what the doctor ordered. Divide it, equals 0.05 grams. Step 2, put it into the equation, dr over ds times volume, and you get the answer. Number 11 was a little bit weird of a setup. Again, Stephanie helped figure this one out. the doctor is requesting 25 milliequivalents, but your supply is in 44.6 milliequivalents in, so it's within, it's a fraction, making a fraction in 50 milliliters. So you have to set it up as a fraction. So you have the dosage supplied, you could flip-flop these, it doesn't really matter, and do DR first, but the dosage supplied was 44.6 in, not per, but in 50, so it's a fraction. And then the doctor wants 25.8, but we don't know what amount of liquid, or this is the volume, we don't know how much volume will equal that amount. So then you cross multiply and simplify, which gives you 44.6x, because we cross multiplied, is equal to 50 times 25.8 is 1,290. Divide by the 44.6 to isolate the x. X equals 28.9 or 29. Oops, 28. This would be 29. Because you would round up because of the 9. So hopefully that helped you out on some of the tougher ones. If you guys have any questions, just let me know.